All right, this is a brief investigation of diatomic elements, and we're going to apply it to real life here and talk about water a little bit. So just take several minutes, pause the video, and write everything down, and then we'll go. All right, key realization here is water is not just water. Even though there are a bunch of H2O molecules, billions and billions of them floating around in this water. I'll just write them like this. Hundreds of millions of those, H2O, H2O. Okay, more importantly for our survival, there are minerals embedded in that water. And what are these minerals? Well, we have our gluin. They are largely in the form of ions. So we see that calcium is a macronutrient found in water, and it's found in soils. Notice it's not found in the pure form of just Ca, but it's Ca plus 2. Potassium is the same way, K positive. They are found in their ion form. So we've got K positive floating around in this water. We've got Ca2 positive potentially floating around in this water for our bodies to grab and use. We've got some magnesium floating around for our bodies to take and use. We even have, you wouldn't think so because we've got hydrogens here, but we even got some hydrogen floating around. Some hydrogen ion floating around. Okay? Then we also have other things floating around that may not be ions. Okay? Things like critical to fish, for example, things like O2. Okay, which is a gas that's trapped in water. And we may even have things, other gases that have been expelled out into the water. Potentially some hydrogen gas, very small amounts, H2, and potentially some carbon dioxide gas, CO2, that's been pushed down into the water or trapped. Okay, so there are ions and even some pure substances floating around in the water, so critical for us just to see that. Okay, notice we didn't just write O in this diagram. We wrote O2. Okay, we did that because oxygen is one of our 7 diatomic elements, and there are 7 diatomic elements. Okay, it's possible there's some bad stuff floating around in this water. Okay, there could be some lead, just straight Pb in small traces floating around in the water. Okay, other not so good stuff that could be in here, there could be just some iron, Fe, floating around in this water through contamination. But notice that the lead and the iron, we both represent those just with their basic symbol. Whereas in the oxygen, we put a 2 behind it. And the hydrogen, we also put a 2 behind it. Okay? There are 7 elements in nature that like themselves so much that they're only found in little packets of 2. Oxygen is one of them. If we quick look at the Lewis dot structure for oxygen, oxygen had 6 Lewis dots, and those dots quickly arrange themselves in the presence of another oxygen to come together like this, and this is how we get O2. So you will never find an oxygen molecule just as an O ever floating around in our world. Okay, it will always be O2. And there are 7 elements that do this. When they are singled up by themselves, typically gases, when you find them in our environment, they are diatomic. Okay? Symbol-wise or picture-wise, we might draw something. You might see them drawn like this at times, just coupled together. And they actually make these 7 diatomic elements. Form a 7 on the periodic table. And that 7 is right here. It's nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And one more, hydrogen. So if you want on your periodic table, you could just put I2, Br2, Cl2, F2, O2, N2, and over here H2. Now again, this is only when they appear by themselves. Okay, I'm going to go ahead and draw that 7 right now. They are hydrogen. And then here comes the 7, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So 7 diatomic elements that when they show up by themselves in nature, okay, they come together with a like element or like atom and form diatomic elements. Now be careful with this because this does not apply when things combine and ionize. Notice that hydrogen here is an H+. That's because it's split off from water and it's an ion, okay? In their pure two things, in their pure elemental form, you would see it as H2. As an ion, you can see it as H+. Another mistake students often make is they take this diatomic element piece and they over-apply it at times. Think back to our naming and what the formula for calcium oxide is. Okay, well, we just go back and we do play this where we have Ca2 plus and O with its ion charge of 2-. So if I was going to name or write the formula for calcium oxide, I would just write CaO. Notice in this situation, oxygen is an ion and it's combined with calcium. It is not by itself, so therefore it's more than okay to only have 1 oxygen in the formula. Okay? The key thing to note is that when oxygen is lone and by itself as a pure element, okay, it couples together with another oxygen and it's always O2. So very different pieces here. Okay, the key thing here, there are 7 diatomic elements, elements that when they are found by themselves in nature, okay, appear coupled together. Those are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine, and they in fact form a 7 on the periodic table. The other thing we kind of picked up here in our exploration moving forward is that water is a carrier of all kinds of stuff. It's a carrier of gases like oxygen and carbon dioxide. It's a carrier of ions that our bodies use like potassium and calcium and magnesium. And it's even a carrier of some toxins that we find in our body, iron and lead. We can get lead poisoning if we have too much of it. So a whole bunch of things in water, and the core idea here of being aware of the 7 diatomic elements and what they are.